In this lesson, we will learn about the different data types, port colors, conversions, and polymorphism. Now, inside ICE, we have to deal with many different types of data and convert between them to create the effects we want. Let's now take a look at a few different data types that we'll run into. Let's start with the basics, integers and scalars. Integers are simply positive or negative whole numbers. 10, negative 25, 134. These are useful for counting objects like the number of particles in a scene. Integers are shown as a dark green port. Scalar values, on the other hand, can have a decimal point, so they can describe pieces of something, like 4.5 or 3.14. This is important when moving from one number to another. For example, to count from 0 to 1 with integers would only have a single sharp jump, 0, 1. If we plugged that into something like opacity, we would not get a smooth transition. For this type of animation, we would want a scalar value because we could take smaller steps, such as 0.1, 0.2, 0.3, all the way up to 1. Scalar data is one of the most common data types we will be working with and is a component of many other data types. Scalars are shown as light green ports. Next we have booleans, which are simply on or off. You can think of a boolean as an integer that can only be set at 0 or 1. In real-world examples, we can see a boolean as a light switch or a checkbox. They are always either on or off. Booleans are shown as orange ports and are used to control checkboxes and conditional statements. Next we have color, which is the first data type with multiple numbers. To store any color, ICE only needs the amount of red, green, and blue in that color. The color data type also stores alpha, which is how transparent a color is. All four components of a color are stored in scalar values. Colors are shown as red ports. You can convert colors to scalar values in a variety of ways, do some math on them, or use those scalar values to drive other things, then reconvert them into a color. Next we have vectors, which are one of the most common data types we encounter in 3D because they are how we store positions. Remember at the beginning when we said that a point in space is defined by three numbers? These three numbers together are called a 3D vector. 3D means that this vector has three components or dimensions. If a 3D position vector was 1, negative 3.5, 4, then we would know that to find that point in 3D space, we would go positive x, 1 unit, down 3.5 in y, and across the z-axis 4 units. In ICE, we also have 2D vectors and 4D vectors. All vector numbers are scalar. Vectors are shown as yellow ports of varying brightness. Next, we have a port color that is not a data type but is important, execution. We plug execution ports into our ICE tree to have our nodes affect the scene. You can think of execution as almost the end of the line. We can only connect an execution port into a small number of inputs, namely the ICE tree, an execute node, or a conditional node to turn it on or off. Execution is shown as a dark gray port. Now there are a few other data types, but they are either self-explanatory or too advanced to cover in this lesson. The other common colors we will encounter are light and dark pink for shapes or geometry from our scene, light blue for rotation, and green for reference, which is just the name of an object. For full creative freedom, we will need to convert our data from one type to another, and we can use the conversion nodes to do this. Remember, we cannot plug two different ports together that are not the same data type. ICE will give us an error. So we need to use the conversion nodes when we're trying to connect different data types together. Now there are some limitations to these nodes in that we will need to convert things to scalar before we can convert them to a different type. Finally, let's talk about polymorphism, a complex name for a simple idea. Let's say we need a node that adds one number to another. Well, we might want to add two integers together or two scalar values together. So you might be thinking of looking for an add integer node and a separate node for adding scalar values. If this was the case, we would have many nodes that do the exact same thing. Instead, certain nodes can change their data type based on what type of data is connected to it. This is called polymorphism because the node can morph or change to different data types. When we connect some data into a polymorphic node to set the data type, this is called initializing the node. So if we want this add node to handle scalar data, we can simply tie a scalar number into one of its inputs or connect its output into a scalar input. Once we do this, you'll notice this port or the port colors change to the data type's colors. Once we have initialized a node to a certain data type, we can still re-initialize it, but we will have to disconnect anything that is setting the data type input and output. Once we do that, we can plug in an integer value and see the port colors change again. On a node's creation, polymorphic ports will be black. However, once something is connected, that port will keep that data type color. To test what data types you can connect, you can hover over the black port. Polymorphic ports can usually only handle a few different data types. So in this lesson, we learned about the various data types we're going to encounter in ICE. Now this is important knowledge because we're often going to have to convert between data types because we cannot connect ports that are different colors without a conversion node. And we also talked about polymorphism, which is the property of some nodes that can change their data type depending on what is connected to them.